Hello students, today we study about electric flux. The word flux means flow. We know which can flow, air can flow, water can flow, and electric field lines also can flow through any surface. So electric flux means it's a measure of electric field lines crossing through the surface. That is number of field lines. How many field lines penetrate through a given surface is known as the electric flux. Example, you consider this surface. When you place this surface in the electric field lines are passing through the surface like this. We know what is electric flux. Electric flux is the number of field lines passing through the surface. We denote electric flux as phi. So here phi is 8 because 8 field lines are passing through the surface. So flux is 8, that is phi is 8. So flux is nothing but number of field lines passing through the given surface is known as the flux. And flux is proportional to the electric field intensity, that is number of field lines. If more field lines are passing through the surface, the flux increases, and it is also proportional to the area of the surface, because when area of the surface increases, more field lines are passing through the surface and flux increases. So we write electric flux as E dot A, that is E vector dot A vector, that is dot product of electric field and the area vector. We know dot product is cos theta, so we write electric flux as EA cos theta. A vector, that is area vector. We know what is area vector. Area vector has a magnitude equal to the area, and it has a direction which is always perpendicular to the surface, and theta is the angle between the area vector and the electric field. Now why we write a flux as dot product of electric field and the area vector, that is EA cos theta. For that you consider this surface, and we know the area vector for this surface is normal to the surface, that is along this direction, and electric field lines are passing through the surface like this, and electric field line is making a angle theta to the area vector like this. Now resolve this electric field into two components, that is perpendicular component and the axial component. This is the perpendicular component of the electric field, that is E sin theta, and this is the axial component of the electric field, that is E cos theta. The axial component of the electric field is along the direction of the area vector. So it is passing through the surface, it is perpendicular to the surface, which is called flux. E sin theta is not passing through the surface, it is parallel to the surface, it is not a flux. So we write flux as axial component which is passing through the surface, which is parallel to the area vector, that is E cos theta into area of the surface. So that is why the flux is the dot product of electric field and the area vector, that is EA cos theta. We know the result of the dot product is the scalar quantity. So flux is a scalar quantity, and its SI unit is Newton per Coulomb meter square or voltmeter. Flux can be positive and it can be negative. When it can be positive, when the field lines are leaving out of the surface, flux is positive, because when the field lines are leaving out of the surface, the electric field lines are parallel to the area vector. So theta equal to 0 degree, cos 0 is 1. So when field lines are leaving out of the surface, flux is positive. When field lines are entering into the surface, the field lines are entering into the another side of the surface. In the another side, the field lines are anti-parallel to the area vector. For this surface, the area vector is in this direction, and electric field lines are entering in this direction. So theta is 180 degree in this side. Cos 180 degree equal to -1. So when field lines are entering into the surface, the flux is negative, and when field lines are 90 degree to the area vector, flux is 0. For a small elemental surface, what is the flux? For small elemental surface dA, the flux is d phi, which is nothing but E cos theta into dA. We write E dot dA cos theta. For a total surface, the flux is integration of E dA cos theta, or we write integration of E vector dot dA vector.